We are again solving systems of equations, which is where we have more than one equation on a graph, and we're looking to see if the two lines intersect, because if they intersect, that point is a solution to both lines, and so that point would be the solution to the systems of equations. If they don't intersect and are parallel, then there is no solution to the system, and of course if the two lines are on top of each other, there are an infinite number of solutions. Now, normally we would graph them. However, in order to graph these, I would have to solve each of these for y equals before I could go graph them, or even put them in the calculator and go graph them that way. So I'm going to show you another technique. We're only going to do the first four problems this way. We will practice this technique at the end of the year after the STAR test, because this is something you will need to know for the TSI test and your college entrance exams. So, and for geometry and algebra 2 next year. So this is a technique that's called elimination method. Some people call it the stack it up method. I always think in my head on stacking them up and adding them. What happens is if you've got the x and the y on one side of the equal sign and the number on the right, and notice this one also has the x and the y on the left-hand side, the equal sign and the 3. So the x's are lined up vertically, the y's are lined up vertically, the equal signs are lined up, and the numbers lined up. What happens is we can draw a line and add these two equations together. I was amazed when I saw this method to see that you could add two equations together. It just kind of blew my mind. So if we add these up, what happens to a positive 3x and a negative 3x? Yes, they cancel out. They are just gone, okay? That just cancels out. This is why the stack up works really well. Now 2y plus 4y gives me 6y. So this is now a positive 6y. The equal sign comes down, and 15 plus 3 is 18. At this point, if you notice, the x's have been eliminated, so now I have a single equation with a single variable, and I can solve it and know what y is equal to. So, of course, this is multiplication. How do you undo multiplication? You divide by 6. If I divide one side, I must divide the other side. So again, whatever you do to one side, you do to the other side. The 6's have now canceled out. Y is by itself. It is equal to 3. So y is equal to 3, and that is part of the point where these two lines intersected. So remember, our solution is going to be an ordered pair. And in that ordered pair, the y number is a 3. So I already know half of my point that the two lines intersect at. Now I still need to find the x number. So what you do is you take the number that you do know, y is 3, and we're going to plug it back into one of these two equations. It does not matter which one you plug it into. You might want to plug it into the first equation. You might want to plug it into the second equation. Since the second equation had this negative sign, I'm kind of like, I don't want to do negatives. So I'm going to do the first one. But again, you could have used either equation. So I'm going to write this equation over. 3x plus 2y equals 15. So all I did was take this first equation and move it over here. What was y? Y is 3. I'm going to plug the 3 in for the y over here. So now I have 3x plus 2 times 3 is equal to 15. So all I did was, we said y was 3, and so I plugged in the 3 there. All I have to do now is solve this equation for x, because x is the only variable in it, and then I will know what the x is in my ordered pair. Isn't this the coolest technique ever? So, of course, 2 times 3 is 6, so now this is 3x. Oops, it's not very pretty. 3x plus 6 is equal to 15. And, of course, the goal is to get x by itself. Which one do we undo first? We get rid of the 6 first. So if I subtract 6 on this side, I must subtract 6 on the other side of the equal sign. 3x comes down, the 6's are gone, the equal sign comes down, whoops, there we go, the 3x comes down, the 6's are gone, and 15 minus 6 is a positive 9. Now, of course, all this little math you can be doing in the calculator, just plain old add, subtract math. Now, this is multiplication. How do you undo multiplication? We divide. If I divide this side by 3, I must divide that side by 3. So 3's are now gone, x is by itself, 9 divided by 3 is 3. So x is also 3. So in my ordered pair, 3 comma 3 is the point where these two equations intersected. All right, so if you were to go graph them, that's the point on the coordinate system where the two lines intersect. So 3 comma 3 is the solution to this systems of equations. It's the cutest little technique ever. Let's go do it again. You're not going to get it the first time. It's going to take you a good 20 or 30 times of doing it before you get good at it. And after you've done a few hundred of them, a few thousands of them, you get really, really good at them. But for now, we're just going to do 4, and then at the end of the year after the STAR test, we'll do some more. Okay, so here's this one. Notice they are stacked up because the x's are lined up together, the y's are lined up together, the equal signs are lined up, and the numbers are lined up. And of course, you could rearrange them if you needed to put them in that order. But they're already lined up for us that way. So these are very simple ones because they already came in this beautiful format. Now, notice when I add these together, are the x's going to disappear or will the y's disappear? Yes, you're correct. The y's are going to disappear when we do this. So I'm going to draw myself a line. We're going to add these vertically. This is a 7 plus a 1 because there's a 1 in front of that x. So 7 plus 1 is 8x. The 6 y's cancel out. The equal sign comes down. And 20 good guys and 4 bad guys. 4 of these bad guys killed 4 of these. So I'm left with 16 good guys. So I have 8x equals 16. Now, how do we undo multiplication? We divide. If I divide by 8 on one side, I must divide by 8 on the other side. 8's cancel out over here, so x is now by itself equals 16 divided by 8 is 2. So x is 2. I am halfway through solving my systems of equations because I know, oops, let me make a better ordered pair. I know in my ordered pair the x is a 2. I just need to find the y number. So how do I do that? I take my x that I do know, and I'm going to plug it back into one of these two original equations. Does not matter which one you pick. This has a lot of negatives in it, so I'm thinking, I'd rather do these multiply positive numbers down here. So 1x, I'm going to use the second one, plus 6y, is equal to, I'm copying this one down again, 20. Okay, so here's my equation. 1x plus 6y equals 20. Yes, that is an equal sign, not a greater than. That's just a plain old equal. It just has a funny thing in there. Okay, so here's the equation I'm going to plug it back into. And again, you could have picked either equation. X is what number? 2. So where the x is, I'm going to plug in my 2. So 1 times 2 plus 6y equals 20. All right, 1 times 2, of course, is 2. So this is just 2 plus 6y equals 20. We're solving for y. I want to get it by itself, so we've got to get rid of the 2 and the 6. Which one do you get rid of first? Yes, you get rid of the add, subtract number first. So instead of adding 2, we're going to subtract 2. If you do it to one side, we do it to the other side. So 6y is now equal to, 6y is equal to 18, because 20 minus 2 is 18. How do you undo multiplication? Yes, we divide. If I divide one side by 6, I must do it to the other side. Oops, finish off my 6. 6 is canceled out. Y is equal to 3. So, now I know the other half of it. Y is 3. So, here's my ordered pair. X was a 2 and my y is a 3. So those two original equations, when they intersect at the point 2, 3. That is the solution to that systems of equations. No graphing calculator needed whatsoever. Aren't these the funnest things in the world? So number 3, again, nice and lovely, easy because they came in this format already. The x's line up, the y's line up, the equal signs line up, and the numbers line up. So I can just look at this and say, okay, is anything going to disappear or eliminate or cancel out when I add these up? Yes, the y's are going to go away. I got a positive 5 and a negative 5. So the 5 y's are going to cancel out. So when I add these vertically, I have a negative 6 and a positive 4. So bad guys are going to win. 4 of these kill 4 of those. So I'm left with negative 2x. The y's cancel out equals negative 5 plus 5. Well, that is also a 0. But I'm going to keep the 0 there. I didn't put the plus 0 here because there was no reason to keep it when I already had something there. But there was nothing over here, so I need the 0 to fill that place. Now, negative 2x equals 0. This is multiplication. This is negative 2 times x. How do you undo multiplying? Yes, you're going to divide, and you divide by the exact same number. Okay? It's negative 2 that's being multiplied. It's negative 2 that you divide by. I do the same thing to this side. And if you're not sure what 0 divided by negative 2 is, put it in the calculator. X is equal to 0 divided by negative 2 is 0. So my x is 0. So in the solution where these two intersect, it's going to be 0, comma something. So my ordered pair, the x is a 0. Now I need to find the y number. So I'm going to take my x and substitute it back into one of these two equations. Does not matter which one you pick. You'll get the same answer either way. So let's see. I'm kind of looking at this and I'm thinking, this one's got 2 negative signs. This one only has 1. I'm going to go for the 1 negative sign. So I'm copying it over. 4x minus 5y is equal to 5. So here it is copied over. We said x is 0. So what is 4 times 0? If I plug a 0 in here, 4 times 0 is 0. So this is 0 minus 5y is equal to 5. I just kind of did that little piece in my head. 0 times 4 is 0. So the 0 is basically gone, right? Yeah, just ignore it. Now, negative 5 times y equals 5. So how do we undo multiplying? Yes, we're going to divide by that same negative 5. If I divide one side by negative 5, I must divide the other side by negative 5. The negative 5's cancel out, leaving me with a beautiful positive y. And 5 divided by negative 5 is a negative 1. So my y is a negative 1. So 0, negative 1 is the point where those two lines intersect. 0, negative 1 is the solution to this system of equations. All right, number 4, last one on these. Same little technique. Here's my lovely equations they gave me. The x's lined up, the y's lined up, the equal signs lined up, and the numbers lined up. So I don't have to rearrange them. They're already that way. Is anything going to cancel out when I add them together? Are you sure? I'm kind of thinking some of you said it's right. These are not going to cancel out, and those are not going to cancel out. This is a positive 5 and a positive 5. That gives me a 10x. They don't go away. So you don't always have equations given to you in a way that will eliminate or cancel out one of the variables so that we can do this little technique. So what you have to do in that situation is you have to change one of the equations to be what you want it to be. Now, the easiest thing I think to change, there's a couple of things we could do. We could make this a positive 3y. If positive 3y and negative 3y would cancel out the y's, right? In order to do that, what that means you're going to do is multiply this whole first equation by a positive 3. Because 3 times 1 will give me a 3 here. But that means this piece also gets multiplied by a 3. So this would become a 15x, because 3 times 5 is 15. So this equation would be rewritten as 15x plus 3y equals, again, you have to multiply the whole equation. So 2 times 3 is 6. So you could rewrite this whole equation changing the y's. But I'm kind of thinking instead of multiplying by 3, I kind of like the idea of just multiplying by a negative 1. Because right now this is a positive 5, and if this was a negative 5, then I could also eliminate the x's instead of doing the y's. So there's a variety of ways that you can eliminate and figure out how to change the equations. I'm just going to stick with multiplying it by a negative 1. So I'm going to take this first equation, and this whole first side is going to be multiplied by a negative 1. And that means the other side is also going to be multiplied by a negative 1. Because whatever you do to one side, you must do to the other side. So this whole thing is in parentheses. So negative 1 times 5 will now be a negative 5x. Negative 1 times a positive 1 is now a negative 1y. Okay, parentheses are gone, equals, and then 2 times negative 1 is now a negative 2. So I'm going to rewrite that equation over here. My new first equation is negative 5x minus 1y equals negative 2. Oops, that equal sign does not look pretty. All right, so I've rewritten this one over here. There's my new equation with the negative 5x, negative 1y, minus 2. So it's no longer this equation. It's been multiplied by a negative 1. My second equation I did not touch. It is still 5x. It is still minus 3y. It is still 14. So if they don't come already with something disappearing when you add them up, then you have to change one of the equations by doing something to both sides of the equation. And there's always a variety of things that you can do to make them to where something will disappear when you add them together. So I multiplied the left side by a negative 1, and I multiplied the right side by a negative 1, and rewrote it up here as this. So now that I have them rewritten, I can add them together. Of course, the x's now cancel out, which is what we wanted it to do. So the x's are gone. Negative 1 and negative 3 is a negative 4y. Equal sign comes down, and negative 2 plus 14 is a positive 12. All right, so negative 4 times y. How do you undo multiplying by a negative 4? We divide by a negative 4. If you do it to one side, we do it to the other side. Y equals, this is a negative 3. So this little solving technique is something you're going to be using for the rest of your career in any algebra or math class. Statistics, you'll be using it in science a lot. So the rest of your high school career and college career, and for a bunch of you that are doing careers that involve more mathy type stuff, you'll be using it forever in your life. So y equals negative 3. We are halfway through this one because we have found the y number is a negative 3. So in my ordered pair, the y is a negative 3. Now, when you get ready to plug it back into one of the equations, you never want to use the tampered equation. So this is the one that I multiplied by a negative 1. You always want to plug it back into one of the original equations. So either I go back to this original equation, 5x plus y equals 2, or I do the 5x minus 3y equals 14. Don't use the tampered one, the one that I rewrote. So I just want to keep it to one of the original ones. So I'm just going to use this bottom one down here. So 5x, I'm writing it down below, minus 3y equals 14. And of course, where the y is, I'm going to plug in my negative 3. All right, so negative 3 times negative 3, this is a positive 9. So 5x plus 9 equals 14. And then we're ready to solve for x. Get rid of the 9 first. We always undo the add subtract first. So minus 9 minus 9. 9's cancel out. 5x comes down. Equal sign comes down. 14 minus 9 is 5. Yep, it is 5. Now, 5 times x, how do I undo multiplying by 5? We divide. So if I divide one side by 5, I must divide the other side by 5. X is equal to whatever 5 divided by 5 is, which is 1. So X is 1. Of course, the 5's canceled out here if you want to do that. So back up here in my ordered pair, X is 1. So the point 1 comma negative 3 is the point where those two lines intersect. And that's how you do it with this elimination or stack it up method. They do these a lot in the college entrance exams. And they usually come in that lovely stacked up form where you just have to maybe do one thing to one equation. So watch the next video so you'll know how to do the next set of them, because I'm going to show you in the next video how to do them in the graphing calculator, quick and simple and easy, and that's how we're going to do them the rest of the year until after the STAR test.